Hi and welcome to another video from Unnati Academy, and in this one I'll be taking this beautiful concept of the unit circle and use it to explain the sinusoidal functions. This is what I do for most of my students who are in 11th grade, and it does a very good job, so I hope it helps you. The unit circle is basically a circle with a radius of 1, and we consider the radius as a vector of unit length which is rotating anti-clockwise. In this case, anti-clockwise is what we assume to just take one direction, and it's rotating at an angular speed of omega, and this omega, the angular speed of the radius vector, is basically in radians per second, and we assume it's going around the circle at a speed of pi radians per second. So pi radians per second would mean that this radius vector covers half the circle in 1 second, because pi is half the circle and 2 pi is the full circle. So how is this related to the sine and the cos curves? The sine curve here is basically nothing but the vertical projection of this rotating radius vector. So the vertical projection of this rotating radius vector is basically the sine ratio, this height divided by the radius, which is 1. So essentially, at any time point t, the angle theta is omega into t, the number of radians per second into the number of seconds elapsed. And if you see the sine curve here, it's nothing but the height of this projection at any point of time t. And you can see that at pi by 2, this goes to 1, and at pi, this will go to 0. And as this radius vector keeps rotating round and round and round the circle, so does the sine curve keep going on and on and on. So the periodicity of the sine curve is directly related to the circle, the vector, radius vector going on in a circle at a speed of omega, and omega, basically the speed of rotation of this vector, is directly related to the frequency of the sine curve. If the radius vector started rotating at double the speed, let's say at 2 pi radians per second, then in 1 second it would cover the whole circle, and hence the sine curve right now it's covering pi radians in 1 second, but if it started rotating at double the speed, it would cover 2 pi radians in the same amount of time, and hence this curve would look like this at double the frequency. Same with the cos curve. The cos curve is nothing but the horizontal projection of this radius vector, and you can see that at angle 0 this would be 1, and that's why cos starts with 1, and at pi by 2, cos pi by 2 is 0, and that's how the cos curve goes. And same relationship between the angular speed of rotation and the frequency of the cosine curve. So that's the unit circle and the relationship between the unit circle and the sinusoidal curves for you. I hope it helped. Thank you so much. Have a fun evening.